Hey everybody, Bill Sky, the C++ guy, back again for another video. And what we're going to talk about today is we're going to talk about functions. Now, functions in C and C++ are pretty much the same. It's just the data types that you can send. In C++, you can send a lot more. But let's get right to it because I love to code, and functions is actually the topic that got me my very first teaching job because they claim I explained it so well. Let's see if I can do the same thing here. So if you've watched some of my other videos in C++, you'll have noticed that I had this thing called clear kin, which was a user input, a cin or a kin clearing and, I guess, protection function that every time you enter in a number, it's good to do this. And so let's revisit that topic as our very first function. So right now I've got a simple little project here. Now you can do this in Eclipse, you can do it in Visual Studio Code, you can do it in just about any IDE, you can do it on command line, doesn't matter. This will work on every integrated development environment. And so what we're going to do is I'm simply going to say, and let's do a hypotenuse thing, right? Hypotenuse seems to be a pretty common example for how to do a function or how to explain functions. But for right now, let's just put in the code that is going to have the user type in some data. So I'm going to say cout, please enter the length of side A. And then I'm going to do the same thing for side B. So I'm just going to output those two messages. And now we're going to need a couple of variables. So I'm going to come up here and I'm going to say, and let's make it a double. I'm going to say side A equals 0, double side B equals 0. And we're going to need a side C, right? Because that's going to be the measurement of the hypotenuse. So I'm going to say double side C equals 0. Okay, so now we've got our variables. Let's go ahead and have the user type that data in. So I'm going to say sin or kin, whatever you want to call it, side A, and down here we're going to do a kin side B. All right, so all we're doing is just testing our user input stuff right now. So let's go ahead and I'm going to say cout side A. Side B. Let's just make sure our data input is working. All right, great. So let's run it. All right, good. Please enter the length of side A. I'll put 23.45. Side B is 67.55. All right, good. That data input has worked. Now, I want to remind you what happens if we don't clear the kin or clear the cin buffer if the user types in some invalid data. So let's say I type in for the first number 23.A45. And let me remind you what happens. Well, as a reminder, what happens is that the cin sees 23 dot, and it says, okay, I'm going to put that into side A variable. However, the moment that it sees the letter A, it says, I don't know what, letter A is not a number, right? I can't put that in to a double variable. I can't put A in there. So it moves on to the next input, and the next input is for side B, but notice it never asked me it never allowed me to type in side B, and then it printed side A and side B, and that's because the cin buffer still had the A45 enter key in it, the new line key in it. So because I typed in some invalid data, I've got to do something in case the user typed in some invalid data, I've got to do something to reset the kin. And you say kin.clear or cin.clear and kin.ignore. I always like using int max. And what that'll do is that will reset the kin, so if I typed in something invalid, we won't have that problem. Now, int max hasn't been defined, so I'm going to pound include climits. And let's retest this. So I'll go ahead and run it. And this time I'm going to type in the same thing, 23.A45. And notice the difference in the operation. It now is asking me to type in B because what those two lines did on line 24 and 25 what they did was basically reset the CN. It didn't, and it deleted any invalid data in there based on numeric input. And I didn't type in a number, I typed in the letter A after the dot. So that's pretty cool. So let's go ahead and put in 65.A56. And now that one seemed to work okay simply because we didn't have any more user input code there. But every time the user types in a number, you should always do this clear kin, and I'm going to just go ahead and do it. We do a kin.clear and kin.ignore. It just should be something by default that you put in there. Well, what's the problem here? This looks fine, right? And we can go ahead and calculate our hypotenuse. But the problem here is that we have a lot of duplicated code. And instead of having a lot of duplicated code and retyping it over and over again or copying and pasting it over and over again, we're actually making our program larger, and it could get smaller, it would take up more memory. The best thing to do is to create a function that includes these two lines of code. So we're going to do that right above the main. So you don't want to do that inside of the main function, you want to do it above the main function. So we're just going to say void, and I'll talk about what that means in a minute, clear kin, and I can name it anything I want, and I'm going to say void in the parentheses, and I'm just going to copy this code, these two lines of code. I'm going to actually cut them and paste them in there, and then I can delete them down here. Now I've created the function called clear kin, and let's look at this a little bit. Clear kin is the name of the function. You could have called it Terry, you could have called it Sally, you could have called it Frank. It doesn't matter. It's just the name of the function. Inside of the parentheses, that's the data I'm sending to the function. Now in the case of this function, I don't need to send it any data. Think of those, and that's called an argument. And think of arguments like a little note you pass your friend, right? You want them to do something, and here's the data that I want you to do it with, okay? So like, I send you a function, or I send you a function called buy me something at the grocery store. I give you the little piece of paper, that's the argument, and the argument has all the things I want you to buy at the grocery store. So that's what the clear kin is. It's a function, but we're not sending it any data. And that's what the parentheses are. This right here is the data that the function is going to return, in this case void. I'm not going to return anything. So now you don't have to have the void in the parentheses, but it's a really good practice to put it there just to document the fact that you're really sending it nothing. It doesn't make your code bigger, it doesn't make the executable slower or larger, but it's a good way to document. Then you've got the open curly bracket and the closed curly bracket. That means that everything inside of those brackets is part of the function, and I want you to execute that code. And then you just put normal code in there. So you just the normal code. Now I put that function in there, and if I save and build it, it builds just fine, but the problem is that I'm not executing that code yet. So this is called the function definition header line, and this is the function body. But now we have to call the function. So to call the function, you simply say clear kin, and you send it any arguments in parentheses. In this case, we're going to leave it blank, and that means we're not going to send any data. Now you can't put the word void in there like you did in the definition of the function. Just leave it blank. So I'm going to go ahead and copy that to the next to the next user input. And remember, we just do the clear kin when we're CNing into a numeric variable, whether it be an integer, a double, a float, a long, or a short, any kind of a numeric variable, even a char. So let's see what happens when I run this code. Okay, so I'm going to put 123.A45. All right, seems to be working. 56, 7, 8. Okay, it worked. There we go, it worked. Now, you might be wondering what happened to the .A45. Well, because I put the A in there, it was an invalid numeric value, so it just cleared the whole thing. So we basically lost the .45 because of that mistake. Now, you might look at this and say, well, you've generated let's say 3 lines of code here. 3, 4, 5. That's 1 line of code longer than just the 2 lines of code at each place. Granted, yes, you're absolutely right. However, what if I had to do that 50 times in a program, which is not unheard of, okay? What if I had to do that 100 times in a program? We're saving a lot of program space by using this function, or creating this function. So there you go. So that's your very first function. Now the next question is, why did I have to put it, or why did I put it above the main? Well, let me show you what happens if I delete it and I put it below the main. And if I try to build it, the compiler says, hey, I don't know what this is. Clearkin was not declared. I don't know what it is. You know, I have no idea, because the compiler works from the top down. So that's why we must put the function above the main, because we have to define it before we can use it. It's like you can't drive a car before you buy it, right? So define the function first, and then you can use it. All right, great. So what's the next thing that we want to do? The next thing I would like to do is I would like to create a function that will actually calculate the hypotenuse of the two numbers that I just entered, side A and side B. And again, you have to add those above the main before you use them. So let's go ahead and do that. So I'm going to say, I'm going to create a function call, actually I'm going to create a function that returns nothing, and I'm going to call it calculate, and let's just say HYP for hypotenuse. And what this function needs is it needs side A and side B. Now what I could do is I could copy all of this into the function, and that would be a valid way of doing it. However, this function could only be used for command line programs. It couldn't be used for graphical user interface programs. It couldn't be used for PHP programs or web-based programs. It can only be used for command line. So it's not a good idea to put the couts and the cins inside of that function, unless, of course, this is only going to be a function for command line. So what we want to do is we want to send side A and side B. We want to send those variables to the function. So for that function to catch those variables, like a baseball player, a catcher catches the ball, we have to give it a glove to catch that data into. And that goes in the arguments, in the parentheses of the function. And we have to specify the type of data. So we're going to say double A, double B, and then open and close the parentheses. So double A and double B, what's going to happen is that when we call this function, we're going to send side A, we're going to send a copy of the variable side A, put it into the variable A in the function. We're going to copy the value from side B and put it in the variable B in the function. So the value that we typed in for side A will be in side A and in A. The value for side B will be in side B variable and variable B in the calculate hype function. So that's called pass by value. It's going to make a copy of the data and send it to that function, and then that function can do whatever it wants with it. So how do we use that function? So what I'm going to do is I'm going to create a variable inside of the function, and I'm going to say double C, and that's how you create a variable inside of a function. And now I'm going to calculate that value. So I'm going to say C is equal to, and the equation is A squared plus B squared equals C squared. So I'm going to say A times A plus B times B. Now we're not quite done yet. We now take that sum of those two products, and we have to get the square root. So I'm going to say C equals square root of C. Now square root itself is a function that's built into the C and C++ languages. And I'm saying, give me the square root of C. Now where did that come from? It came from the pound include, or the hashtag include CMath. So you have to make sure that you have that in your at the very top of your program, so the calculate hype can use that function. And then I'm just going to see out the hypotenuse is C. All right, great. Let's see how this works. I'm going to run it. All right, let's say the length is 23.45. Side B is 567.98. And it printed... Oh, wait, I forgot to call the function. Duh. So, okay, so after they type in side A and side B, I'm going to come down here and I'm going to say calculate hypotenuse, side A and side B. Boy, look at what Eclipse did for us. I didn't even have to type it in. All right, so calculate hypotenuse, side A and side B. So I'm going to save and build that, and let's run it. 23.45, 568.99. All right, pretty cool. So here is the length of the hypotenuse for a triangle, a right triangle, that has 23.45 as side A and 568.99 as side B. Now I would actually verify this in a calculator to make absolutely sure that number is correct. I'm going to leave that to you to do it. Okay, so let's take a little bit closer look at this function. Now I said earlier that the reason that we don't want to have the calculate height function do the user input is because we don't want that function to only be usable on a command line application. We would want to sell that function, let's say, to other programmers who might want to use that function in their graphical user interface program, or maybe even in their web-based program, or maybe their iPhone program or Android program. Well, we have a problem here is that we're still requiring that because we're using cout. Also, main, after it calculates the hypotenuse, it can't print C. If I say count C, it doesn't know what C is because C was not defined in the main. C was defined in here. So the variable C can only be used in that function. So how do we communicate to the outside world after calculate height is done calculating hypotenuse? How do we let them know that, hey, this was my calculation and I don't want to do it this way? Well, one way we can do it, or the best way we can do it, is we can say return C. And the return statement says leave the function and send whoever called the function the value in variable C. And the function in variable C has the length of the hypotenuse of the right triangle. Well, we have an error right here because it says you're returning a value that you didn't tell me about. That's because we're saying in the function header that we're returning void. So we have to change that to double. And when you change, in this case, double. If you're returning an integer, you would say int. If you're returning a long, you would put long in there. But in this case, we're returning a double. All right. So if I go ahead and build that, we still have some problems. Let's take a look at the problems. Oh, it still doesn't know what C is. So when we call the function, how do we capture the value that I'm returning? Well, we created a variable up here called side C, and I'm going to put that here. I'm going to say, hey, side C is equal to calculate height, and then I'm going to say cout side C. So how does this work? So what's happening is that when I have the user type in side A and B, we all should understand how that works. We print out side A and we print out side B. We really don't need that anymore, so I'm going to comment that out. And then what we do is we call calculate height. We send side A and side B. Those are the variables the user typed in their data. We call that function. We send those two pieces of data. Then up here, we capture those as variable A and variable B, A and B. We create a temporary variable called C within the function. We calculate what C should be based on A and B, which if you remember, those were copies of side A and side B, which the user typed in. And then we return C. What happens? The value in C is now copied into side C because we said side C equals whatever calculate height returns. And then we're going to cout side C. Now Eclipse shows that there's still an error there, but if I rebuild it, the problem goes away. So now my main can do anything I want with that variable. Let's say if I want to say cout side, or no, C doubled is side C times 2. So we can do anything we want, some strange stuff. So side C contains that value. And I'm going to build it, and I'm going to run it. So let's do it again. I'm going to say 23.45, and 78.21. All right, pretty cool. So we see out inside C, there is my hypotenuse length, and then we also have it doubled. I don't know why I did that, but that value got put into side C. And we might want to put something a little bit better here. Calculated hypotenuse is, I don't know if I spelled that right, so that looks a little bit better. Let's run it again. Looks much better. There's your hypotenuse value right there. So that's what the return value does. Now, if I say return an integer instead of a double, and I try to return C, I think it'll compile, but we're probably going to get a warning. Well, actually, we didn't get a warning. I'm trying to return a double because C is a double, but I'm trying to return it as an integer, so what happens? The decimal point is dropped off. So let's see how that works. 23.45, 78.21. Oh, I gotta rerun it. Hold on, I pressed enter too fast. 23.45, 78.21. So you can see the hypotenuse is now 81 instead of 81 dot additional numbers, and that's because we returned an integer. Now, if I turned on different error messages or warning messages on the compiler, it probably would tell me, warning, you're returning a different data type than you said you're returning. So that's a function that returns a value, and it also accepts values. Now let's say we want to reorganize our code to make it a little bit more visible. Let's say we just opened up this program for the first time, or this project, and we see these functions. Where's main? We have to go looking for main now. Okay? So normally programmers do not put functions at the top of above their main. They put them underneath. But there's a problem with that, and we saw that earlier. If I cut those and I put them below the main, now when I open my program, I see main on top, but it won't compile. And the reason it won't compile is because I'm trying to use functions that I haven't defined yet, and then I define them after the fact, after I've used them. The compiler says no, no, no to that. So to fix that problem, there's this concept called prototypes. A function prototype is simply telling the compiler this is going to come later on. I'm not going to define it here, but it's going to come later on. So for instance, I'm going to say void clear kin, and that is a function prototype. It doesn't have any content, it doesn't have an open and closed curly brace, but it shows the prototype above the main, which tells the compiler it's about to be defined somewhere later. So just go ahead and do main, and then I'll define it later on. And we need to do the same thing with our calculate height. And that took a double and a double. Now, on a prototype, you don't have to put a variable name here. You don't have to actually put a variable. You can, and it's actually a good idea to document your function prototype, but you don't have to. You can just put the data type. Now we have a little problem here on the actual definition. We put double. So let's change that from int to double. Okay. So these are function prototypes, and I normally like to say a comment there and put a comment there just to kind of tell everybody what's going on. So now it compiles just fine. So what does the compiler actually do? The compiler says, okay, I'm going to include these things. I'm going to use the namespace std. And the programmer's telling me that there's two functions coming up. One is called clear kin. Another one is called calculate height. And okay, so I'm going to put a little sticky tag on those. And every time I see them, I'm going to know what the programmer's talking about. I'm going to take the word of the programmer and say, okay, they're going to define that later, so I'm not going to give you a compiler error. And then I define them down here below main. So the program is a lot easier to actually view. But it's still kind of messy. So what actually happens? What does a professional programmer do? Well, normally what they'll do is they'll create a header file to include all the function prototypes, and then they'll show the implementation of the functions in another C++ file. So let's do that right now. Let's make our program even more usable. That means that I can also share those functions with other programmers without actually letting them see my source code. Or maybe I want to show them my source code, but I don't have to give them my main. I can just send them my functions libraries. So let's do that next. So what I'm basically saying here is I'm going to separate my functions from my main program. My main program is still going to use them, but I'm going to put them in different files so I can share those files. So the way that I'm doing that is I'm expanding the CPP functions project. I'm expanding source. I'm going to right click on source and I'm going to say new header file. And I'm going to call this header file myfunctions.hpp. And the reason I say .hpp instead of .h is .h is assuming it's for C. .hpp means it's for C and it's for... Actually, let me say that over again. So a .h means it's good for C and C++, because C++ is built on top of C. .hpp means that it's only good for C++ programs. And in this case, that will actually work. We can say .hpp or .h here. However, if we use strings or anything like that in our functions, we have to make it HPP. I just keep it at HPP all the time. So what has been created here is a header file that has some preprocessor directives that don't allow that header file to be defined twice, and that's a completely different discussion, and I'll do that in an upcoming video. But what you want to do is you want to put your prototypes in between the hashtag define and the hashtag end if. So I'm just going to go ahead and copy these, or I'm going to cut it out of my main. I'm going to put it in my HPP file, and I'm going to save and build this. Okay, so it didn't build. Why didn't it build? Because my main doesn't know what clearkin is, and the reason is because we moved those prototypes out of the main file and we put them in the HPP file. So how do we fix that? You're going to love this. We pound include myfunctions.hpp. So we have moved the prototypes out of our main and put it in myfunctions.hpp, and now when I build it, it builds great. But we're still not done. We still have our functions in the main. So what I'm going to do is I'm going to go into SRC, I'm going to right click, I'm going to say new, and where does it source file, and I'm going to name it exactly the same as HPP, except with the CPP at the end, and press finish. It's completely empty. Now I'm going to go back into my main. I'm going to highlight the functions below my main. I'm going to cut them, and I'm just going to paste them into the myfunctions.cpp. Now myfunctions.cpp doesn't know anything about cin or anything, so I'm going to have to do a pound include iostream. I'm going to have to do a using namespace std. Okay, that's pretty good. It doesn't know what int max is, so I'm going to say pound include int, oh, not int max, c limits. And I have to do a pound include cmath as well. Well, aren't I duplicating code? Because didn't we do that in our main? So we did it in our main, so we have to do it in our myfunctions.cpp. I have an even better solution. How about putting all of that into myfunctions.hpp? In myfunctions.cpp, we pound include myfunctions.hpp. And in our main, since we're including myfunctions.hpp, we don't need any pound includes. Because what's going to happen is our main is going to say pound include myfunctions.hpp. Myfunctions.hpp is going to include all of this, because what the include does is it just copies and pastes it to your main. MyFunctions is also including myfunctions.hpp, so it knows everything about cin, it knows everything about square root, it knows everything about int max. So we've put everything in my functions.hpp that my program and my functions needs to operate. So I'm going to click Save All, and I'm going to build. You're going to see how beautiful this is. So it builds perfectly. And now here's my functions.cpp. Everything is great. Except we haven't tested it yet. So let's go ahead and run it. 23.45, 78.21. It works fantastic. So what's the benefit of all of this? All of this work that we did? Well, let me show you the benefit. I'm going to go up here to say File, New, C++ Project, CPP Manage Build. I'm just going to say Test CPP. I'm just going to get rid of it. So, or even better than that, delete me. I'm going to call it delete me. I'm going to say hello world. Turn off release. And there's delete me. Now watch what I can do. I'm going to select the My Function CPP, and I'm going to press Shift on my keyboard. I'm going to click My Functions.hpp. I'm going to right click on it. Right click on it and say copy. You can do the same thing on Windows. Then I'm going to go to my new project, delete me. I'm going to right click on the SRC and I'm going to say paste. Then in my delete me project, all I have to say is #include my functions.hpp. And now I have complete access to those two functions that I previously created because I copied them to my new project. I don't have to write that code again. That's unbelievable. It's just going to make your coding so much better. And there's another step that you can take, which is instead of copying the source code, just copy the header file and link your program to the object file created by myfunctions.cpp. That's a different subject. We're going to talk about that later on in videos. But this is a way that what you do is you separate your main from your other functions by putting them in myfunctions.hpp and cpp, and then you can reuse them over and over again. But let's go ahead and do what I said. I'm going to delete this project. Oh, I pressed paste, so I'm going to delete it again. And I'm going to click delete project contents. Okay, because we're not quite done yet with functions. Functions is a pretty big subject. The one last thing I want to talk about functions is when we talked about, when I call calculate height, remember earlier I said that the side A that the user typed in, a copy of it is put into the A variable in the calculate height function. Side B, whatever the user typed in, a copy of that is put into the B variable. That was called pass by value. I made a copy of it and put it in those variables. Well, that could be a problem. What if I'm running out of memory? What if my program is huge? What if I'm dealing with a small program? I don't want to make a copy of the data. I don't want to use up memory that I don't need to use up. And there's even a more technical reason for doing this. But I just don't want to make a copy of it. I want to send the real side A, and I want to send the real side B. I want to send those to that function, the real one, not a copy, but the real one. Let's say I want those values to be zeroed out by that function. Okay? So if I come up right here into my functions, and if I say A equals 0, B equals 0, I'm not zeroing out side A and side B. I'm zeroing out A and B. I'm zeroing out the copy of those. But what if I want to zero out the actual value from the main? Well, the way to do that is, it's very simple. It's a little bit cryptic, but it's very simple. You put an ampersand in front of your variable names. And that's called pass by reference. And you do that in the myfunctions.cpp, and you also do it in the myfunctions.hpp. So you do it in the prototype, and you do it in the actual definition of the file, of the function. So what does that actually do? Well, let's go ahead and let's get rid of those ampersands, because I want to do a little demonstration without them. So in my main, what I'm going to do is I'm just going to print, and remember I had this C out here. I'm going to put that C out down here. And that's after I called calculate height. I'm going to save and build that, and I'm going to run it. And I'm going to say 23.45, 78.21. Okay, so my side A and side B still have the values that I typed in. However, didn't I move 0 into A and B? So that proves my point. It did not actually change side A and side B when I moved 0 to A and B. It changed a copy of side A and side B. And that's why that is proof that it didn't modify the original variables. However, I'm going to put an ampersand in front here. I have to do it in the CPP file, and I have to do it in the HPP file. And I'm going to save and build this. Now remember, it didn't change them before the ampersand. They had the actual values that I typed in. So let's save and build this now, and let's run it again, and let's see what our results are. Whoa! 23.45 is no longer inside A. 78.21 is no longer inside B, and that was from our C out in the main. Why? The reason is because we said don't send it by value. Don't send a copy of the variable to the calculate height function. Send the actual variable, the actual memory location of those values. And then when I change them, A actually is side A. It's like a shortcut to side A. B actually is side B, a shortcut to side B. However, without the ampersands, we're modifying a copy which doesn't modify the original. So that is called pass by reference. And sometimes it can be very, very useful. Sometimes it can be a little confusing. But you need to think, do I want calculate height to really modify those variables? In this case, I don't think I really do. But I want to leave the ampersand there because I want to send the actual variable. You might not want to put the ampersand there if you don't want the function to modify the user's data. I mean, how would you feel if you were going to use my functions libraries that I just sent you, that you can, you have permission to use these, and you find out that my functions are modifying your main variables? You might be really upset over that. You might not like that at all. I'm not going to use that person's program anymore or functions anymore. So you want to make absolutely sure that you do that in a responsible way. And I think in this case, since calculate height really isn't a huge function, it isn't causing a lot of memory situations, and really, do I want to change it? No, I don't. So I'm just going to leave those as pass by value. Now another thing that you can do inside of a function is you can say that I want those to be constants. So I want A to be a constant, and I want B to be a constant. And you have to do that in both the prototype and the actual implementation of the function. Now, why would you ever want to do that? Well, let's say you want to make absolutely sure that the function doesn't modify A or B. Remember that A equals 0 and B equals 0? Well, if I put the word constant in front of those variables in the function definition and the prototype, the compiler won't let me do things like that. It will actually protect the integrity of those pass by value or pass by references. So it won't actually let me modify them. Okay? So that's a very useful thing too. That way you can make sure that as a programmer, you don't do something stupid in your function. And it's actually very common to put const up here because those are just readable values. You don't want to actually modify them. You want them to be read-only. And let's make sure that our changes are still working for us. So 23.45, 78.21. Yep, it's still working great. All right, so that's an introduction to functions. Oh my goodness, we talked about pass by value, we talked about pass by reference, we talked about sending arguments to a function, we talked about returning values from a function, we talked about separating our functions out into their separate CPP and HPP files. What a great video this is, because we taught you so much. Go ahead, rewatch it, jump around the video, practice these skills, and you're going to be a function expert very quickly. Hope to see you in our next video.